All you need in life is a color picker willing to expose you to the unbounded madness we call color vision. Me, absolutely clueless. I want a color just like this one, but in red. Color picker. Fuck you think you are, a mantis shrimp. Don't talk to me again until you can afford a wide gamut monitor. What is even happening here? Where's the circle with the triangle inside we all know and love? The circle and triangle are a lie we tell ourselves to cope with the ugly reality. Now this is the real deal. In seriousness, this is OKLCH.com, a color picker for the OKLCH color model. There are whole several-hour lectures one could take in color science and theory, but to keep it short, the set of colors we can see, the set of colors the monitor can display, and the set of colors computers can model are three circles that only somewhat overlap. In this case, if I wanted this color, but in red, I could just go to Photoshop and move over the hue slider, getting this as a result, which is acceptable, but not as bright and vibrant as the green I had. Looking at the graphs in the OKLCH color picker, we can figure out why. It tells us that a red with the same luminosity and chroma as this green is out of gamut, that is, it cannot possibly be displayed by this monitor. In this case, you can use the edges of the graph to find the color that is closest to what you want. You can, for example, keep the chroma, but sacrifice the lightness. Keep the lightness, but drop the chroma. Or a bit of both, which is what the common HSV triangles already do. We'd like to know when it happens, you know? Color can be described in two ways, and one philosophical way. We're going to start on the left, go to the right, and then go down the middle. So, color is three primary colors mixed together, which is kind of three-ish primary colors mixed together, that being the red-green-blue model, the red-yellow-blue model, the cyan, magenta, yellow, and key model, key meaning black. Color is a rainbow, and each color is a wavelength, which means that it's a mix of infinite wavelengths filtered through three eye pigments, those being red, green, and blue. A few months ago, scientists simulated cells in the back of our retinas to be able to make people see a new color, known as OLO, but some experts have said that the existence of this new color is open to argument. The reason that we can say that this is seeing a new color is because there is an overlap between the red sensing, the green sensing, and the blue sensing cells in the back of our retinas that basically mean that we can't actually truly see certain colors because the overlap is always there. But by mapping out the retina and being able to stimulate certain cells, you can potentially see new colors. And I'm sure that the graph that I've shown for this is highly simplified. Now, in a philosophical sense, you cannot know that what I see as blue is the same as what you see as blue, but we can safely just kind of like assume that it is the same because of biology and such. Occam's razor means that the choice with the least assumptions is likely the right one, and if we assume that we are all individually unique, then we kind of create a whole bunch of mess philosophically. And then we get insane with stuff that I don't quite understand with abstract multidimensional gamuts filtered through inconsistently implemented devices and color profiles, and hyperdimensional four-sided quantum Klein manifolds, which are a thing, I'm pretty sure, but I've got no idea what they are. I've heard those words before, and well, you know, it's someone else's problem at the end of the day, but you can still research it if you want. That last section is very interesting. Even just the section about, like, how our eyes work and seeing new colors is very interesting. The irony of it all is that the colors that that person who originally posted this was seeing are probably different to the colors that I'm seeing now that I'm editing it, and probably different to the colors that you are seeing now watching it because of the different ways that devices send out different colors. So, none of it was the same. Good luck figuring that one out in your head. Feel free to correct me in the comments if I've said anything that was incorrect, because I'm obviously not an expert. I've done some research for this, not as much as other people have done. Even the Dunning-Kruger effect has a Dunning-Kruger effect. I've listed all the sources in the description below, including XKCD's Evolution of Understanding of Color Over Time. XKCD does a lot of amazing stuff. Please check it out if you're interested in just things generally. And also, I guess, subscribe and follow me on Twitch. I don't know.